Picture this. You're sitting peacefully at home, maybe having a cup of coffee, when suddenly the floor vibrates violently. Within seconds, your entire city is transformed into a disaster zone. There's no warning, no escape, just absolute sheer chaos. It is pretty shocking to think about, but every single year, our planet experiences more than 500,000 earthquakes. Out of all those, roughly 100,000 are actually felt by people, and a few hundred of them cause absolutely devastating destruction. Now, this crazy high frequency of destruction brings up a terrifying mystery. What enormous hidden force has the power to just shift entire landscapes? I mean, why does the solid ground we completely trust suddenly turn against us? Section 1. Inside our layered planet. Earth is not a solid rock. To really get this, we have to look down. Down at the very center, you've got the inner core. It's a solid iron sphere hitting nearly 5,500 degrees Celsius, which is basically as hot as the surface of the sun. Then comes the liquid metal outer core, which is actually what generates our magnetic field. Above that sits the massive mantle. Now, it's solid rock, but because it's under so much heat and pressure, it behaves more like extremely slow-moving putty. And finally, sitting right on top, there is the crust. And to put things into perspective, compared to the massive size of the Earth, the crust we live on, where literally every single city, mountain, and ocean exists, is actually thinner than the skin of an apple. But here is the real kicker. This incredibly thin crust is not just one solid, unbroken shell. It's actually cracked into about 15 major tectonic plates. You can think of them as enormous puzzle pieces floating on that thick, putty-like mantle, almost like giant icebergs floating on a sea of honey. Because they're floating, these trillions of tons of rock are constantly in motion, but they only move at a speed of about 2 to 10 centimeters per year, which is, crazily enough, the exact same speed your fingernails grow. It sounds totally harmless, right? But remember, we are talking about entire continents in motion here. Section 2. How tectonic plates collide when unstoppable forces meet. So over millions of years, these unimaginably heavy puzzle pieces bump into each other in 3 main ways. First, you have convergent boundaries, where they crash together and the denser plate subducts, meaning it sinks below the other one. Second, divergent boundaries, where they pull apart to let magma rise up and create brand new seafloor. And third, transform boundaries, where they slide dangerously sideways against one another. Section 3. The anatomy of a quake, from tension to explosive release. Let's look a bit closer at those sideways sliding transform boundaries, like the famous San Andreas Fault. As these massive plates try to slide past each other, their rough edges snag and lock together. The rocks act almost like giant springs, bending, twisting, and compressing. Pressure builds up for decades, sometimes even centuries. But eventually, the stress is just too much. The rocks violently fracture and snap into a new position, releasing centuries of stored pressure in a single instant. That instant release creates what we call seismic waves. And man, they are fast. These waves race through the Earth at a blistering 30,000 kilometers per hour. That is over 8 kilometers every single second, which is literally faster than many bullets. Those waves actually arrive in phases. First, we get the P waves, or primary waves. They're the fastest, compressing and stretching the ground, and they usually serve as our brief initial warning. Then, right behind them come the S waves, or secondary waves. They are a bit slower, but so much stronger, aggressively moving the ground side to side, which is what actually tears buildings apart. Section 4. Measuring massive destruction. The math behind the magnitude. When this incredible energy finally reaches the surface, scientists obviously need a way to accurately measure the terrifying scale of the destruction. To do this today, they rely on the moment magnitude scale. This is the modern replacement for the old Richter scale, and it's designed specifically to measure the total energy released by these enormous events. Now, because the scale is exponential, even a tiny jump in numbers is deeply terrifying. A magnitude 8 isn't just slightly worse than a 7. No, it is roughly 32 times more energetic. That means that magnitude 9 unleashes over 1,000 times the destructive power of a 7. Every single number up represents a massive, massive escalation in devastation. We have witnessed this 1,000-fold devastation historically. In 1960, Chile experienced a mind-boggling magnitude 9.5, the strongest ever recorded, and the ground there shook for nearly 10 straight minutes. In 2004, a massive 9.1 in the Indian Ocean triggered a deadly tsunami that claimed over 230,000 lives. And in 2011, Japan faced a 9.0 that quite literally erased towns and caused the Fukushima nuclear disaster.
Section 5. Predicting the big one. Can science warn us in time?
Well, it's complicated. Scientists know exactly where earthquakes are likely to happen, and they know exactly why. They monitor fault lines constantly using advanced GPS satellites, lasers, and seismometers. But here is the really hard truth. Predicting the precise minute, hour, or even day the ground will actually fracture is still completely impossible. Instead, our best defense right now is earthquake early warning systems. These systems are designed to detect those initial super-fast P waves we talked about earlier. By catching that first signal, they can offer a precious 5 to 6 second warning before the slower, far more destructive waves hit. Now, 50 seconds might sound incredibly short, but it is enough time to stop a speeding train, shut off gas valves, and take cover. It literally saves lives. And honestly, we are eventually going to need every single second of that warning for the big one. The big one is a massive, absolutely inevitable release of tectonic stress looming over major fault systems, like the San Andreas Fault in California or the Cascadia subduction zone. No one knows if it's going to happen tomorrow or centuries from now, but make no mistake, the stress will eventually be released. Ultimately, these terrifying events are just a profound reminder that our planet is alive. As this quote perfectly captures, the Earth isn't trying to destroy us. It's simply doing what it has done for over 4.5 billion years. The exact same forces that build beautiful mountains and shape continents are still working beneath our feet every second of every day. Our world is constantly shifting and evolving, just like it always has. As we wrap up this explainer, I really want to leave you with a thought to ponder. If scientists suddenly cracked the code, right? If they could predict earthquakes perfectly, down to the minute, how do you think our cities, our infrastructure, and our daily lives would change? Think about it. And remember, the greatest mysteries aren't always up in the sky. Sometimes they are hidden right beneath your feet. Thanks for learning with me today.